Hey guys, I want to talk to you about parent functions. The equation, the function name, the graph, what it looks like, how to remember them. Quick overview of all the 10 different functions we're going to talk about for the rest of the school year. So let's get started. Here we have the constant function or the linear function. The way to remember this, or the way I like to remember this, right? Constant has the letter C, so the function is going to be y, or let's just use f of x to be consistent. F of x equals c for constant, which means in your graph, whatever number you choose, right, whatever number you have, it'll be a constant number, right? It'll be just a constant value. This is your x-axis, this is your y-axis, just to not confuse them. Their constant is going to be constant. No matter the input, right, you're going to have a consistent and the same output. For linear function, well, this is basically Algebra 1 and pretty much everything you did in Algebra 1, right? Your linear function, the way you probably remembered is y equals mx plus b, but the general parent function is f of x equals x. I like to think of the word line. It's a straight line. This is from linear, right? This is how we remember it. So we have our function is going to go through the origin. This is our x, this is our y-axis, so our function is going to go right through your 0, 0. Your slope is 1, your y-intercept is 1, which is why here we have a 1 as a slope, and then a 0 plus 0. So technically this is mx plus b, except that the b is 0, and then the m is 1 over 1, which is what gives you that process. Here we have the quadratic and the square root functions. Now, I put those two together because they are inverses of one another, right? The quadratic function is a parabola. I like to think of the u here, right? So my function is going to look like the letter u. Let's see. And again, it's going to go through the origin. So here at the origin, we're going to have the letter u as the quadratic. Now the function, right? Another way to think about the quadratic is we're dealing with x squared. So the function is f of x equals x squared to the second power. And this allows me to move over to the next topic, which is the square root. Since we're dealing with a square, right, the inverse, instead of multiplying two numbers like 4 times 4 to get 16, we're going to do the inverse operation, which is the square root of 16 gives you 4. Right, so our function itself is going to be f of x equals the square root of x. It is the inverse operation from here. Here we're multiplying a number times itself twice. So 3 times 3 gives you 9. Here we take the square root of 9 to get 3. So we're trying to find the root of that actual square. Right, we're trying to find the root value of what it gives us. So this parabola, right, is going to be basically tilted on its side. And our function is going to look like this. Again, our x-axis, our y-axis, and then our parabola will be sideways, starting at 0, 0. The reason why we don't have this part down here is because, remember, it has to cross the vertical line test. And the vertical line test, I'll change this up for a second so you can see. The vertical line test, if I put my pencil, it cannot have two outputs, right, for that thing. So the function is going to focus on the positive side of things. So remember, your function will look like just half of a parabola on its side, starting at 0, 0. Again, these two are inverses of each other. They are inverse operations of each other, which means we are doing the inverse operation. Right here we're multiplying the number by itself to get the other number. Here we're going to do the opposite. We're going to find what number is multiplied to give you that bigger perfect square. But yeah, the letter u gives me the u, and the square root, we're taking the root of that kind of number. Here we have another set of inverses, right? Cubic, I like to think of an actual cube, right? A cube, I'm going to try to draw this a little bit, not cubey, but cube. The cube will look something like this. right? A cube has 3 dimensions. It has length times width times the height. Length times width times height. So a cubic function will have f of x equals x cubed. That is the actual function. It's got 3 dimensions that it's going to go to, so we're multiplying a number times itself 3 times. So unlike the quadratic that did it times itself twice, this one is to the 3rd power, so 3 times. The function here actually starts looking very interesting. It looks kind of like an S, right? It's going to still go through the origin and then go up in that direction. That's your cubic function. Now the cube root, again, very much like the square root. Now we're dealing with the cube root. So we're going to be taking this function, and it's kind of like square root of x, but we're doing the cube root. So there's a small little 3 right above it. We call that we'll talk about what that means and then how it works, but that little 3 is a cube root of it. So now we're looking for a number multiplied by itself 3 times to give you that number. So here we did, for example, 2 times 2 times 2, we got 8. The cube root of 8 is 2, because 2 times itself 3 times gives you the 8. So you're going the opposite direction, which is why this graph is going to be flipped sideways. And it's going to look like this. It should be going through origin. There it is. All right, next 2. Here we have the exponential and logarithmic function. Now exponential, these 2 again are also inverses of each other. I like to think of exponential with the first 2 letters, ex. That's how you know the name of the function. The exponential function has f of x equals e to the x. Now, x is now the exponent, which means that the graph is going to grow exponentially. We'll talk more about this later, but for now, we're going to move from the left side and exponentially increase to the right. Okay, this is never going to touch the x-axis. There's a horizontal asymptote here. It's like an imaginary boundary that we're going to talk about later, right? There's an imaginary boundary here on the x-axis where the graph is going to get really close to the graph, but it will never cross it, and it'll grow to the right direction. It's going to be exponentially growing as it goes that way. The logarithmic function, right? The logarithmic function is the inverse operation. Now, the log function, I'll take these 2 right here, or these words right there, and my function itself is f of x equals the log of x. That is the inverse. Now, you might see it as log of x, or you can also see it as ln of x, which is the natural log. Again, we'll deal with these as we get closer to the end of the year, but the inverse operation of exponential, right, is logarithmic. Here, it increases exponential. The other one sort of plateaus at that same rate. So the graph is going to look like this. Now the vertical asymptote is going to be on the y-axis. So I'm going to cross the y-axis. The function is going to get really close to it. That's not a very good picture. And sort of flatten out. Over here I made a mistake. I should have drawn this one in blue to make it stand out. Okay, so think about inverses as this point, right? Choose a point here. Let's say it's x comma y. We have some point there, x comma y. That same point over here is going to be flipped as y comma x. We'll talk more about inverses later, but that's a good way to find out. Another way to find out if they're inverses is that it sort of looks opposite, right? It gets like flipped from this side to this side. Kind of like mirrors from each other from here to here. All right, let's talk about the last function. Again, these 2 were also inverses of each other. The last one is called the rational function. This right here to me is the funniest one because rational means, well, more like this is the most irrational function to me, right? This function is going to be f of x equals 1 over x. A rational number is any number that can be expressed as a fraction, right? And that's why we have 1 over x as our scenario. You cannot divide by 0, right? You can change 2. 2 is the same thing as saying 2 over 1, right? So you can make any whole number a fraction. A fraction is already written as a fraction, right? So you can put basically any number you would like as a fraction, with the exception of a few numbers, like 0. You cannot divide by 0. You cannot put 0 as a variable in here. You cannot do 1 divided by 0. This means undefined. It is undefined. This number does not exist. It's really impossible for us to define what it means to divide something by 0. If you take a pizza and you divide it into 0 slices, like, how does that work? Because if you don't cut any slices into them, don't you still have 1 slice out of the whole pizza? That's what's so irrational about this process, right? You can't divide by 0. It's an irrational thing to do. So the function is going to also look very interesting. We have our x, we have our y. This one's going to have 2 vertical asymptotes. Sorry, 2 asymptotes. A horizontal one on the x-axis and one through the y-axis. And the function is going to look like this. On the left side, and on the right side, give me 1 second, on the right hand side, it's actually going to be flipped here. We have, it starts in the negatives, there it is, and over here it goes on the right side, positives. So the reason why here on 0, 0, nothing is touching the x-axis or the y-axis, because at 0, when you put it in, it doesn't work, right? If I plug in other numbers like 5, it becomes 1 over 5. It's just a decimal. So as the numbers get bigger, this fraction gets smaller and smaller and smaller. If I put 10, something over here, 1 divided by 10, you should get 1/10, so a small decimal. All right, guys, I hope this helps. I hope this helps you sort of get a bigger idea or view of what this function looks like and what all our 10 functions look like. There are some keywords that you can use in each one of them to help you see how to remember the functions, what they look like, what the function actually is. The goal is to be able to identify the name, the function, and the graph. Hope you guys are having a great day, and as always, I'll calculate later.